Once again, the only thing you have to pay attention to this talk is this URL at the top. That contains a pointer to software. If you're a developer or no developer, write that down, and it will have the code and the data and everything I'm talking about. So I'm here to teach you to fish. I'm not, we're not into selling you fish. We're into selling you tools so you can fish for yourselves. All right?
I'm not a programmer, so was it meaningful to me?
So anyway, what do? We make link pipe to Java API. It gets used a lot. It's open source. It's dual license. It's commercial terms and free versions. We're not an official open source license. We have our own version. It's a little more viral, a little more allergic to commercial entities, but it's how we make our money, right? So it's a dual licensing arrangement. And wow, that's really interesting. Okay. And the other thing we do is we do custom research and development, and we do training. We're kind of like a boutique NLP firm. We tend to work with people, with companies that already have research groups. If you have developers, you want to learn how to do things like sentiment analysis and natural language processing, we're kind of the people you come talk to.
Wow. So this is a sentiment analysis school for programmers.
All right, so where am I going to go? In 4 minutes, I'm going to go through, talk about topic discovery, which is open-ended, and then a little bit of sentiment, how to build your own, how to roll your own. This is an afternoon's work for me. We're going to compress it to 4 minutes. And what we're going to do is get some tweets as a Twitter feed, serialize that to disk so we can actually play with it. Then we're going to do a latent Dirichlet allocation over it, sort of do some topic extraction, and just to look at that a little bit. It's kind of cool. We're going to annotate about 500 tweets, not right now, but that's the idea. Then we're going to do supervised machine learning over a logistic regression classifier, also known as max entropy, also known as a single neural network. And then we'll ponder what it all means.
Oh, okay. Cool.
Okay, so this is much source code, and we pay attention to it. This is how you get Twitter data using JTwitter. It's not our package, but it's about that much code. It's no big deal. It's boilerplate. It's there. All right. Now, oops, wrong direction. And what that produces is we have an ant task that's available, and you just run say what query is Obama, and then you're going to get a bunch of comma separated value data back written to disk someplace with the same name as that, with a little blank category in the middle, and then a bunch of numbers, and then the tweet. All about Obama. What do you do with that? Oops. It's the right direction. Cancel. Wow.
Allow.
Wow. Thank you.
Okay.
Wow, thank you, Adobe. The machine interface. Okay, how do you get this into the system? So we have a corpus object. This is how you represent information that we're going to play with the system. And it's basically going to have a while, and then you're going to go pull it out of the CSV file. You can split it. You're going to give it a classification using our classification class. And then you're going to handle it, which is part of our cross-validating corpus, which is an instance of.
Oh.
All right. Come on. Okay, and then LDA, latent Dirichlet allocation. What we're doing here is there's a lot of boilerplate getting stuff off the ground. These are kind of fairly fancy techniques. They're very academically driven, but we got industrial implementations. You get the boilerplate, it's there, and then you can just run it. It's just not that hard, guys. And what do you get out? You get clusters. You say how many clusters you want, 10 in this case. And here's the first top cluster over Obama. We see HTTP. You want to pay attention to the z-score. It's right here. 1.7, that's a little low. We go down to 7.6. It's being talked about a lot, 82 times. Nuclear, okay, keep going down, 1.2, 6.5. Summit, oh, nuclear summit, world security leaders around it. You can see this whole topic that kind of popped out. You didn't know about it. This was just something that came from looking about it. I think 400 tweets. The next topic is not so good, right? It's kind of crappy. But that's what NLP does sometimes. It kind of gives you output you can't really use, but human beings are good at supervising it. Obama, new support hits, new love, not so great. All right, so we'll go into it. The next two cluster I found is 5, which is topic 5. We have Supreme Court stuff going on. And that's kind of interesting. So it's a way sort of for data exploration. So we're going to LDA take you. It kind of drives discovery if you don't know the categories. It's a good mix of capabilities. You have computers which are good at coverage, have a lot of memory. LDA is good at summarizing trends a little bit and kind of figures things out. It's a little automagical. And then human beings, you want to put them in as sort of the final filter arbitrary. So, next one is, we're going to do some supervised work now, which is basically classical sentiment in the way that people have been talking about. You go through this middle column here, you see positive, positive, neutral, positive. Actually, we found a lot of spam. This is dragging dictation. So we added in a spam category to try and throw those out too, right? You want to automatically categorize these. And what happens then is you end up with, this is a cross-validation run, and we're running 10 false, which you can train on 90% of it, evaluate on 10%, go, rinse, cycle, and repeat, alternating the 10% slices. And you have a confusion matrix at the top, which is a nice way to view it. And the performance is not bad. The overall accuracy is 83% over this very simple implementation. We haven't done anything fancy at all. We haven't done tuning or anything like that. And in the end, you could end up probably doing about 10% of the work to find all the positive sentiment in there. When you drop about, maybe about 20%, right? 20, 30% gets dropped into because that's performance